Okay, guys, so section 3, the second video, I want to look at number 16 in the book, okay, and I ended up just writing it out because it was short enough. And number 16 on 1.3 says, after a 30% price reduction, okay, you purchase a dictionary for $30.80. So that's with the price reduction, $30.80. What was the price before the reduction, the original price? Okay, so we got a 30% discount. Okay, so what does that tell me? What useful information? Well, if we got a 30% discount, then what that tells me is that 70% of full price, 70%, that's what we paid, right? If it's a 30%, 30% off 100% is 70%. We paid 70% of full price. That's $30.80, okay? Now that I've realized that, I want to just go ahead and put that into an equation form, okay? Well, if you remember, okay, 70%, we have to write that as a decimal, so 0.7 of full price. Well, what does of mean? If you remember, of is one of those math words that means to multiply, okay? So I'll call the full price P. So I have 0.7 P right here. 70% of the full price is $30. So what does is mean? Well, that's 30, that's equals. That's equal to $30.80. From here, it becomes pretty easy to solve. You just have to divide both sides by 0.7. 0.7 and 0.7, just like so, okay? So I end up with P is equal to whatever $30.80 is, divided by 0.7. And what I'm getting here, when I do that, is it looks like $44 was the original price. Okay. So $44. Okay. So sometimes you just have to ask yourself, okay, what are they giving me? Write it out in word form and convert it to an equation. The next one I want to look at is number 26. So you might want to look at it in section 1.3. You can even give it a try first if you'd like. But the whole situation is you have a swimming pool in which the length is 3 times as long as the width. So what good does that give me? Well, that gives me this. L, which is the length, is equal to 3 times the width. Why do we care about that? Well, they want to know the dimensions. We know the perimeter is 320 feet. Let's think about the equation for perimeter. Perimeter for a rectangle is 2 times the length plus 2 times the width. Now, if I fill in what I know the perimeter is 320. But when I look at this, I have no idea how to solve for L and W. I can't solve for 2 variables in one equation. So what am I supposed to do? Well, that's where this little fact comes in. And I can make a substitution in for L. Once I do that, I'll have it all in terms of W, and you can solve for W and back solve for L. Okay? So if I do that, if I write it with that substitution, I have 2 times 3 times the width plus 2 times the width. Notice how now it's just W. I can solve for W. 320 is equal to, I got a 6W plus a 2W. Combine those like terms, so we're using all that algebra we were just learning, or reviewing, I should probably say. And finally, you got to divide both sides by 8 to get W by itself. And that should end up giving us the width. Let's see what happens, okay? So the width is equal to 320 divided by 8. And that should end up being 40, okay? So we have 40 right here, okay? So the width is 40 feet. And the length, how do I figure out the length? Well, the length was 3 times the width, so that's 120 feet. And of course, you can check these numbers to make sure they do in fact give you a perimeter of 320 feet. Okay, so this is a good example of reducing an equation that has 2 variables to having just 1 variable, then solving and back substituting. The last one I want to look at, and once again, I probably should have said this earlier, go ahead and try these problems before you watch me work them out. Not a bad idea. Pause the video, okay? I want to solve this guy for r, because sometimes we're working with an equation and we want to solve for some other variable. So how the heck do I do that? Well, there's a few different ways. I could use the LCD and eliminate fractions. The other way I want to remind you is this. I'm going to write s as s over 1 is equal to c over 1 minus r. And you may be wondering, why are you doing that? Keep in mind, I'm still trying to get r. Why am I doing that? Well, if you have a rational equation in which there's only one fraction on each side of the equation, there's a nice little trick. You may remember it from high school called cross multiplication, right? And cross multiplication, it does the same thing as eliminating the fractions at the LCD, but it's a lot quicker. Once again, you can only do it when you have a fraction equal to another fraction. So let's do that. So I get s times 1 minus r is equal to c times 1. That looks a heck of a lot nicer to solve for r. Keep in mind we're solving for r. So what I could do from here, there's a few different ways. You could distribute, or you could divide both sides by s and then get r by itself. I think it might be easier to distribute. So you get s minus sr is equal to c. And I'm still looking for r. I'll subtract s from both sides. If I do that, not 8 minus s minus s. I see I got negative SR equals C minus S. And finally, I want to divide both sides by negative S since I'm looking for R. If I divide both sides by negative S, I get this. Now, that is technically correct, but the book will probably write it like this, I'm guessing. Just like so. And the reason is, it's a little nicer. We usually don't like a negative in the bottom. But the reason is if we write it like this, we can do this. If I move the negative up top, right? Notice these are the same. It doesn't matter if the negative is on top or bottom. And then distribute the negative. Then you can see that's how we get here. And that's a really dark spot. So let me move that over. Take a look at that, make sure you see where that's coming from. Okay. And you can solve for r. All right, that does it for section 3, guys.